up all the way to the very front. It's a requirement. You there in the back corner. All right. I'm going to just briefly, maybe a quick raise of hands. How many folks were here for the last session? In this room, yeah. Okay. And then how many folks are new to this room for this session? Welcome to the best room. You guys are going to have the best time. For those folks that are new, just a quick safety announcement before we get started. So if we need to evacuate this room, we're going to go out these double doors in the back on the left and the right up here. And then we're going to go left. There's the big main doors that you came in. We'll follow the road there all the way past. There's like a fountain all the way past the fountain to where the road kind of meets the main road. And that will be our gathering area. So just keep that in mind in case there's a need to evacuate. All right, so this is our EV panel, our EV topic number 2. We recently just were chatting about residential charging, although I think it very quickly morphed into everything EV, which is awesome. I'm glad, because it is all intertwined. This one is going to be focused more on some of the challenges that we're facing for affordable, timely connections for DC fast charging and for fleets. And I am joined today by a couple of awesome SMEs. So Nick Morelli is an expert business analyst on the clean energy transportation team. Jennifer Goncalves is a supervisor on our electric distribution planning team. And then Apollo Gomez is a manager in our service planning and design team. And my name's Lydia Krefta. I'm the director of the clean energy transportation team at PG&E. All right. So we're going to dive into some of the key challenges that we're facing that we're hoping you all can help us solve when it comes to DC fast charging and medium and heavy duty vehicles. First, for those who are newer to this room, I'll just do a quick kind of acquaintance with our overarching goals. And those goals are kind of what's driving our desire to innovate and kind of execute on a lot of this electric vehicle work. So overarchingly, PG&E has a goal to enable 3 million electric vehicles to be connected to our grid by 2030. The vast majority of that number, I would say, is light duty, but a lot of the load that comes from that number is medium and heavy duty, and then the DC fast charging stations that serve those light duty vehicles. And then of those 3 million vehicles, our goal is to have 2 million of those vehicles, at least 2 million of those vehicles participating in vehicle grid integration applications. And so that's everything from vehicles responding to passive time of use pricing via our rates, all the way up to active managed charging and even bidirectional charging, providing energy back to homes, buildings, and to the grid. And with that, I'm going to hand it over to Nick, who's going to provide kind of an overview of some of the challenges that we're facing, and then we'll dig into it.
Great. Thank you, Lydia. Good day, everyone. So before we jump into the problem statements and solutions that we laid out in our strategy guide, we want to spend a little bit of time level setting on the amount of growth in electric vehicles that we've seen in our service territory, and also some of the trends that we expect to continue as we continue to support this transition to electric vehicles. So the chart that we included on this slide shows adoption of EVs in our service territory over the last 6 years. We're proud to have supported the connection of over 426,000 EVs in our service area, which represents actually 1 out of 7 electric vehicles adopted across the country. So this growth that we've seen is very steady, very rapid growth, but as we look back over these last 6 years, we see a growth rate of 25%. But now as we look forward of the 2030 target that we set of connecting 3 million vehicles, we're going to need to actually see that growth rate increase to 28%. So pretty quickly, what has been very rapid and exponential growth can start to look relatively flat just looking 7 to 10 years into the future. Also worth noting, as Lydia already called out, the majority of these vehicles adopted to date are light-duty vehicles for personal use, but with the regulations from CARB, the Advanced Clean Fleet regulations taking effect next year, we expect to see many more medium and heavy-duty vehicles begin to be adopted, and with these larger vehicles come much larger load requests. To put some of the size of these load requests in perspective, our service planning and design team, we've already received numerous applications between 5 and 50 megawatts. So looking to put that size in perspective, the size of these loads are typically associated with connecting entire neighborhoods or even small towns and cities. The difference being when we connect these more traditional loads, we usually have many years of visibility to this load before, as these neighborhoods are being planned, designed, and constructed. And then even once constructed, sometimes it could be a number of years for the load to actually materialize in these areas. But now looking at electric vehicles, we can see these systems go from planning and design through to construction in just a matter of months. So there's a huge shift in the quantity, the size, and the speed that these systems need to come online to keep pace with the regulations. We can even go a little bit further and take a look at the SB 671 analysis performed by the California Transportation Commission. This looks at infrastructure needs for medium and heavy-duty freight vehicles. They're forecasting a need for hundreds of thousands of ports to support medium and heavy-duty freight electrification, and 20 to 50,000 of these ports being high-powered DC fast charging stations. So if you look at DC fast charging for light-duty vehicles, we'll see power ratings from 50 up to 200 kilowatts. But with medium and heavy-duty vehicles, these can range from 350, 500 kilowatts, all the way up to 1 megawatt plus per vehicle. So really the theme of today's conversation is how do we make sure that we can connect all these vehicles in a timely and affordable way? And next, I will pass it off to Jennifer here to talk about capacity.
Thank you, Nick. I'm Jennifer Goncalves, Supervisor, Area Planning and Tools. We do load forecasting. And so capacity constraints are really a big deal in many areas. And as Nick was explaining, that's because EV fast charging and fleet is large. So I'll give you an example of a 5 megawatt charging station or fleet station. That's kind of medium sized. That's not even the big 50 megawatts that we're talking about. That's 1,000 to 2,000 homes worth of load. But as Nick was saying, those homes take years to build and charging stations take months. So timing is an issue. But what if we could have those homes and the EV on the same circuits together? What if they talk to each other? The EV says to the homes, how much are you using? I'm using this, and they talk back and forth continuously. So there's ideas where we can have load of different kinds peaking at different times on the circuits. And that's really part of where we want to go to. So I'm going to pass it off to Nepal to talk more about the timelines and why it's difficult to get the EV fast charging and fleet charging.
Excellent. Everybody hear me okay?
Everybody got it.
I've got a mic. Okay. Good afternoon to the folks online and for everybody here. So again, Napalo Gomez, work in our service planning and design organization, head up a team who's focused on commercial EV charging. And so that encompasses partnership with Jennifer's team, really from the point of service applications to the design work to contracts executed to work moving into construction. To the previous slide actually, over the last couple years, we've seen our active volumes grow about 3x. That's putting pressures on just the normal processing of how we move work from beginning to end. So I think there's opportunities there for innovation that we're continuing to look at. Also with the major developers that have portfolios of work across our service territory, obviously there's business pressures, there's the movement of work as fast as possible, but we run into constraints with both our infrastructure that exists currently as well as just our interaction with the broader ecosystem that helps us build this infrastructure for our customers. I look at the growth that we are both seeing in real time and the projections that we have through the various forecasts, and we are going to need a lot of innovation that hits, again, to the beginning of how we support the work up front, to the design work, the engineering, to ultimately how we coordinate work into construction. I think that the partnerships that we start through this effort, the conversations that we need to have are going to unlock opportunities that we just haven't fully realized yet at a scale that is most necessary if we're going to hit our overall 3 million target. So as far as the forecasting tools, I did want to say a couple things about that if that was an appropriate time. So I think the challenge I find ourselves in is that we're very much we react to what the market is doing right now, right? We have applications for service, we have load requests, we design these projects to essentially align with our standards and how we would serve that load, assuming that that's new load and modeling that to our peak to what our circuits are going to ultimately realize, but that doesn't necessarily pencil out with what our customers need. Timelines don't match up. So I think there's opportunities for how can we bring on as much load as possible? Can we manage it in a dynamic way? Are there ways we can send price signals? Themes that we brought up in the previous session that I think are also applicable in the commercial market segment. We just haven't fully figured out the how to deploy that at scale. And so I think there's opportunities there that allow us to bring more fleets on, to get more infrastructure open in a timely way that will ultimately sync up on these longer cycles of having to build some additional infrastructure. So I think those are some of the key challenges in front of us.
Yeah. And sticking with the forecasting for a little bit, we've definitely been investing heavily in forecasting and spending a lot of time because we know that there is going to be a lot of work to do on our system, and we're communicating with customers, purchasing large data sets, running machine learning models to develop propensity or adoption propensities, but there's still a lot of unknowns that are going to dictate exactly where and when capacity is going to be needed on our system. And in a lot of cases, fleet owners are still working through these unknowns themselves. Is my fleet going to go hydrogen or battery electric? Am I going to be charging at my existing depot location, or maybe offsite at a shared location? Or maybe the operation of the vehicle requires that vehicles charge when in use, and they're leveraging public charging stations or opportunity charging at warehousing logistics centers when they're loading and unloading goods. So these things will become more clear, but maybe there's innovation to collect this information from customers and then translate it into actionable forecasts that we can bring into our planning process.
I missed the point. I wanted to bring that up because we're not necessarily in the business of telling customers you should go here, over there, and yeah, definitely over there, right? We're very much in a reactive state with applications that come into us. And while we have invested in these new geospatial tools, I think it's trying to align what's happening in the market, where we have the ability to take on that additional load at the lowest societal cost and realize some serious construction efficiencies in the overall deployment of that infrastructure. So that for me is really exciting, is how we merge those up. And speaking to this next slide here, I think that's where there's again ripe areas for innovation. We've been talking with some of our major customers around real-time pilots on how we can manage load and bring on as much chargers as possible that don't necessarily create a safety situation with our circuits. So I think that's an area we're going to continue looking at with larger fleets on how we can utilize existing assets as well as get that infrastructure in the ground as fast as possible. And I think there's also a lot of opportunities when we look at how do we cost effectively deploy more storage onto the grid in a way that optimizes what we ultimately need to perform, right? Because we've got our existing generation assets, we know our peaks on our circuits, but if we've got all this new load coming on, and this has been a theme throughout the day thus far, how can we do this in such a way that we're not seeing that peak, right? And I think that's where we need more conversation and more partnership. And I think maybe I'll just close with our processes from a utility standpoint. It's not just a PG&E perspective. I think more kind of industry-wide, right? We have certain ways we've always run the business from the beginning of the process to the end of the process. That doesn't necessarily align with what market needs are, specifically in the EV space. When we look at fleets and we look at everything that's going on and all the push across the state of California, right, to realize this transportation electrification vision overall. I think tools that help us align our business and industry needs as well as possible with the EV market is ultimately going to unlock even more innovation and business efficiencies. And so that's why we're here. And I think we're ready to open up to maybe some questions in a little bit. Lydia, did you have any other comments you wanted to bring in?
No, I think that was great. So we'll open it up for some questions. The cadence we'll try to do is a couple in the room here, and then we'll go to the webcast and get some from the webcast. Brian is going to be our mic runner, so just raise your hand. If you can just state your name, your affiliation, and your question. We will try to answer as many questions as we can and probably throw a lot back at you to help us answer. So I think we can start over here on the far left. That was, sorry, I'm making you all the way around. He was up there first. We got to give him the gold ribbon.
Hi, I'm Vince with Electric Fish. You mentioned the integration of storage to sort of promote quicker and more efficient deployment of DC fast charging. I'd be curious about PG&E's evaluation of the trade-offs of non-wireless alternatives, and relative to some of the grid modernization efforts that are happening. So some of those capacity upgrades which need to happen, but aren't meeting the timelines of customers. So I'm wondering if you see sort of that trade-off of where non-wireless alternatives are more relevant, and if they're more of a transitional sort of solution in your perspective, or if they're here to stay.
I guess I'll grab that, and maybe if you have a comment or two.
Yeah.
Is that all right?
Yeah, why don't you start?
Okay.
And I can jump in.
Non-wire alternative, I hadn't heard that term in a while, so thank you for bringing that up. So I'm aware of situations where customers have deployed storage to manage load at their own site. Whether that was a deficiency on the utility side or not, it was a solution that was deployed, not necessarily incented by the utility. I think that's where perhaps there's opportunities for us to be looking at scenarios where that might be a more economical solution than a large-scale, quote-unquote capacity project. Obviously, it's going to have to align with what the load request is, what the conditions are on our existing circuits, right? Because we have to ensure system safety and that we meet our voltage requirements under Rule 2, which was mentioned in the previous session. I also think the one unknown that I can't answer specifically is just the cost trend of battery cells, right? And what we've seen in the market. We had Elon earlier today, and the innovation that Tesla has driven from the manufacturing scale that they brought forward is the reason we see a lot more of this in the market. And there's other players, obviously. Is there a scenario in the future where it is more economical to deploy quote-unquote distributed storage? I mean, that's a possibility, but I'd be purely speculating. I'm curious what your thoughts are from a distribution planning,
Right. So
perspective.
effective battery storage has to have that charging window. And when you look at certain specific locations, specifically along Highway 5, Highway 5 was put where there was no infrastructure for a reason. You could go fast, there's no cities, there's nothing there. The problem with there's nothing there is there's no ability to charge off of the very limited infrastructure that is there. So there are places where it's very tough. But before you jump into battery storage, sometimes you may want to look at PV, because there's places on the system that peak at night because of PV, but then there's the downtown areas, industrial areas, Tejon Pass, peaks at 2 o'clock in the afternoon. Where's all the PV? Well, because it wasn't residential load that got added there, it's industrial load, it doesn't have the PV. So there's solutions, but you kind of have to look at specifically what the time of peak is. They're very customized solutions. So yeah, those are definitely answers, but you kind of pick, it's going to be specific to location. Yeah.
Wow. Poor Brian. All the way back around this way. You got it. Steps. Yeah, right here. Where you started. I just wanted to send you that way, send you back this way.
Hi, Noel Chrysostoma from the U.S. Department of Energy. I appreciate the conversation and kind of realization that we have to go much faster and be creative. One of the challenges that I was lamenting to read in the Wall Street Journal last week was interviews with some PG&E and Edison folks about the scarcity of charging and the multi-year delays. I've been tracking 2 bills that were seemingly complementary or contrasting in California recently. AB 671, which pertains to power control systems and flexible interconnection, similar to what you were describing in the last session, Lydia, and SB 410, which allows for proactive electrification or proactive upgrade planning for electrification. And I'm curious about how those two can continue together given the ongoing supply constraints in transformers, switchgear, the time to commission, plan for all the upgrades, because the deployment of these vehicles is seemingly running into long-held questions at the CPUC related to service planning, right? The green parts of the host and capacity analysis maps and the high DER proceeding is supposed to help exactly this problem, to value the DERs to avoid those upgrades. And so I'm seeing like a tension between those two means of integrating vehicles. Power control systems to avoid upgrades, in which apparently there was opposition to that bill by the utilities, with the Powering Up Californians Act, which allows for that proactive rate making, essentially. And so how do we overcome the, I guess, regulatory or financial barrier to seeing these less as opposites, but things that we need to do immediately in order to keep pace with the customers and regulatory demands?
So I can maybe start, and then I think, Nick, it might be interesting if you can talk a little bit to some of the ICA load map updates that we're thinking about. And then I don't know if you guys have anything on supply chain challenges, but I do think...
I have a couple comments, Lydia.
What was that?
I have a couple comments. I can come in at the end.
Okay, cool.
Yeah, thank you.
I think we need both, right? I think we need to... I recently heard, I think it was the CPUC kind of framed some of the challenges here in terms of like short, medium, and long term, which I think is a good way to bucket it. Short term is like, you've got customers, they're like ready to go, they've got chargers, they're about to have chargers, and we need to make sure that we can get them connected today. Something like a flexible service connection can help with that. And then there's like the medium term where you've got customers who are starting to think about electrification, trying to figure out where should I electrify. I have like a warehouse here, a warehouse here, and a warehouse here. How can I get better transparency into like where there's capacity? And I think the ICA maps to an extent can help with that. And then there's a lot of opportunity to improve those ICA maps, which I think Nick can talk about in a second. And then the longer term piece being like the proactive capacity, right? How do we ensure that we can fund and deploy proactive capacity to make sure that we're getting ahead of some of the timelines that Jennifer spoke to, right? These projects that are much quicker than like building projects. Like how are we making sure that we're using data to identify where we need to do some of this proactive upgrades and then do those upgrades. So I think like both of those things, right? Managed grid management, flexible service connection, providing transparency, all of that, super important. And then we also need to be simultaneously building. And I think like ideas that you all have that can help us with both of those or anything else in between are really important to us. And maybe I'll turn it over to Nick and Paula to talk a little bit more about some of those specific pieces.
Yeah, it's quickly on the ICA map. So within the high DER proceeding, there are some enhancements come into the ICA maps to have a better indication. Currently, they look very historically at what the circuit behavior looks like, but we're also working on pulling in our forecast, pulling in plan work, also applications that are in process, so that those can really be a better reflection as to where there is, or what the current status and future status of capacity looks like on those circuits, and therefore be more helpful for siting. But there's probably still a lot of opportunity for broadcasting that information so that people, when they look at their area or where they're thinking about plotting charging stations, that they'll be able to be more informed as to what the actual status of currently is and what the future looks like, and build their plans around that.
All right. The big T word, timelines, right? So I think there's been a lot of legislative activity around this subject of timelines, right? And from the utility perspective, right, we've been aware of supply chain constraints for the greater part of 2.5 years, really coming out of the COVID pandemic. I think we've made some great strides in working with supply chain upstream manufacturers, actually many domestic manufacturers, to build out additional production capacity, specifically around like conductors and transformers and stuff. So I feel like we got ahead of that from a utility perspective. But when I look at the broader industry challenges like switchgear and panels and stuff, those are things that slow down timelines for our customers, right? For the industry to deploy more chargers, right? This is where I think there's an opportunity perhaps for more partnership in our advocacy efforts and collaboration from, federal, state, and industry-wide, so that we actually have the capabilities to deploy more of this infrastructure to reduce said timelines. Because really, so much of our conversation today is really around timelines. Like how fast can we do all of this, right? And we know we've got constraints in certain buckets. So I think that's where there's more opportunity for collaboration and open dialogue. I think sometimes, we might advocate a certain position, and that can be critiqued. right? And there's counter arguments to this. I think ultimately we've got to find a path forward where we're working more together to bring timelines in versus finding space to be at loggerheads.
Yeah, I'd encourage rapid decision making so that we don't take until the end of the EPIC 4 application process for us to move forward. Strongly support getting to the point. Thank you.
Why don't we take a question from the webcast?
Yes, we have just under 200 online attendees joining this session. The most voted question is this. Oh, a new one just showed up. Here we go. The most voted question is now this. For what time frames would you most like to see forecasting products?
What, could you repeat that again?
Or what time frames would you most like to see forecasting products? If we're thinking about forecasting the EV demand on the grid, like what time frame do we think makes the most sense?
So which time frame we would want to see decreased?
No, like if you were, like, do you want 5 years, 10 years, 13 years, 100 years of like forecast data, right? As we're thinking about what the grid looks like with EVs coming onto the system.
So which time frame do we want to look at?
Well,
I think
Okay. What forecast period would we look at? I'm going to go with all of them. It depends what we're looking at, and part of it is I know I live in the distribution world, but that is not the only world out there. There is transmission, and there is generation, which is also known as resource adequacy, which I think is a lovely term. So I think for that longer, it depends how long it takes to deploy stuff. So in the distribution world, we can kind of react quite a bit faster than the transmission world, and they can react quite a bit faster than the generation world in their traditional kind of bulk generation model. And that has to do with, a lot of it has to do with permitting, honestly, is why those timeframes are much longer, and the cost of that investment. So I think it's going to depend. For us, we go 13 years out right now because that is the California Energy Commission, the IPR, which is the Integrated Energy Policy Report that we use for forecasting. So 13 years gives us that kind of view into what's coming. And when we do investments, we make sure that it's big enough to meet that 13-year need. But transmission and generation resource adequacy, they go out further. So I don't know. Any comments, you guys?
I could just add on. With any forecast, the further that you go out, the less certainty that you have. But at least in California, we have regulations in place that do add certainty to the forecast, like the CARB ACF regulations going out to 2045, I think. So that really helps from a forecasting perspective to include that. And then the job that I have in working with distribution planning is how do we now disaggregate that down to the local level so it's actionable from a circuit, transformer bank, those portions of the system, and be able to build to it that way. But the longer the better with the forecast, but we want to make sure that when we are building assets that we are confident that this load is materializing.
Let's do one more from the webcast, and we'll go back to the room.
The next question is, how comfortable are you with relying on fleet customers using software to drive off-peak charging versus requiring some hard controls by the utility to make sure the grid is not placed in jeopardy and limit need for capacity upgrades?
Yeah, I can take that as far, and maybe if you want to chime in. So we're gonna install, general statement here, right? We're gonna install as a standard business practice protection equipment that protects the distribution grid from our load customers, right? So in a scenario, if I understood the question correctly, where we have a load request that outstrips our current circuit capabilities to serve, and a customer is deploying a combination hardware-software solution to essentially manage that charging, we would do some validation activities, up front before we would energize that service. And I think right now, as I look at, we have various pilots operating, right? there might be unique use cases where we actually want to use that and have some empirical data, right, to build on and maybe build a broader case, right? We need to either develop a new standard, right, or we develop another program that incents a certain technology. So I think these are, again, opportunities for us to bring some more innovation into the market. And I think on our side, we would just ensure that we have the right protection equipment so that the grid is kept safe. Anything, Jennifer? Did I miss?
I mean, that is the intent here. The Innovation Summit and the R&D strategy report is like, let's work together and get comfortable together. These solutions are going to be necessary, and let's make sure that we work together to make them happen.
All right, I think we had a question.
Thanks. Hi, everyone. Zach Wugin with the Vehicle Grid Integration Council. My question is about PG&E's discussion and actual formal proposal for transportation electrification advisory services. And I guess there's a few key questions. One is, there's a number of organizations today that provide this same sort of service out in the marketplace, ranging from charging companies, infrastructure firms, and vehicle manufacturers as well. So what is sort of, in an ideal world, where's the line, sort of what's the role for utilities in providing these services in a market where they're provided otherwise? The sort of more nuanced version of that too is in the near term, recognizing that maybe there are areas where the market isn't showing up or really providing adequate service in this space to customers. Where is PG&E identifying those sort of problem areas or areas where there's more friction than others? And then lastly, how do we ensure that to the extent utilities and PG&E specifically are involved in providing these services, that they're not inadvertently steering customers maybe away from solutions that are best for the customer or that might be more innovative and more challenging or might bring on sort of other questions about the utilities or PG&E's involvement in the project? Thanks.
Yeah, so maybe what I'll do is I'll break that down to the challenge that we're trying to solve, right? Because I think that we've proposed one way. I would say, like Nick said, the purpose of the summit is that we're open to many ways, but I think one of the things that we see is so customers, in particular medium and heavy duty fleet customers, they can come to PG&E in one of two ways. They can either go through Napalo's team in service planning and design, or they can come through PG&E's EV fleet program where we provide some behind the meter incentives for them to install their infrastructure. And through both of these different pathways, if you look at the total timeline to connect a customer, it's quite long. And I think a lot of that falls on the utility side, some of that falls into permitting, but a lot of that falls into the customer side when they're trying to make decisions, right? A lot of times we'll have customers come to us who want to do a large load study, and then once we go through that study, they've completely changed the types of chargers or the power of the chargers that they want to connect. We'll spend a lot of time talking to customers, helping them to understand the different vehicle options available to them in the EV fleet program as they kind of try to get comfortable with the number and types of EVs that they want to install. And so if we're looking at kind of an end-to-end cycle time and how can we reduce that, because we know we need to reduce that if we're going to meet the state's goals, what we're trying to do is provide educational services to customers where we see those gaps, right? Where we see customers looking to us, asking questions, asking for help, looking to find ways to bring down the total cost of ownership of their fleets and trying to step in and provide some of those educational services to help just narrow down that time frame, while also I think simultaneously working on the other pieces of that time frame. So that's really the challenge I think that we're identifying and what we're trying to solve with some of our TE advisory services proposals. And I would say if there are other things that we should be looking at, other tools, other types of education, technologies, all of these things, we're asking you guys to help us think through that. So I think that's the challenge, right? And so let us know what other things we should be thinking about and looking at. Anything you guys wanted to add? Cool.
I think that was a great answer.
Yes.
Hey there, Ferdinand Chanko, EVgo. I just wanted to highlight the mention earlier around transparency. in some of the ICA mapping. I think it's critical to understand current state of the grid from a site acquisition perspective, right? There was mentioned earlier that the typical process is an application puts in and we get some kind of response around whether or not capacity is available. I think the critical nature of that is trying to be forward thinking and trying to figure out, hey, where is there opportunity versus where is there constraint? And then on top of that, I wanted to bring up a point on tariff ruling. It seems as though Rule 29, though it is beneficial on the financial side, it seems to have to cause some delays on construction timeline, where historically the applicant has been responsible for execution. What are your guys' thoughts on that shift and whether or not there's opportunity in somehow shifting that back to the developer, the applicant, and somehow helping to streamline the process?
So I got a few questions there that came out. So one was on the ICA map, so I wanted to make sure we grabbed that one, and then secondarily was around the Rule 29 as opposed to Electric Rule 16, 15. So I think I can grab this. Do you want to speak on the ICA, or do you want to?
I can start with the ICA. So on the transparency front, I think you're absolutely right. It's not just about where we constrain, but where is there opportunity, and if there are innovative ideas or different ways that we can broadcast that information, we'd love to hear about it and integrate that into our process and into our online map. So that's a very important part, and something that we're looking at different ways of pulling that information together and sharing it out to the industry, so we can really focus the growth on where there is available capacity and make sure we have that moving. And then again, when we do have constraints across the grid, be able to leverage these other solutions that we highlighted in the report there. But I'll pass it to Paula for
Anything else?
Just one thing. Right now, just so you understand, the ICA maps were developed for actually generation hosting capacity. So they don't include the low queue of application. They don't include the growth. So that is definitely the next iteration of ICA must include that and will include that.
Are we able to share the timeline for the ICA map upgrade, or is that still going through a proceeding?
I don't know. Do you know?
Okay.
Nick?
not enough to quote here.
Okay.
I
Sorry,
think
we
it's
will
still,
have to get
well, I
back to
think it's still going through. I think it's still going through a process, because I think it's more at a California level. There's a broader recognition that we need better public-facing tools that help the EV charging community, if you will, right? Identify, how to really gain some cost efficiencies on where to build that infrastructure, right? So I think that is one of the pressing industry challenges in front of us. Yeah, definitely. With respect to our EV infrastructure rules, I want to make sure the folks that are on virtual as well hear this. So our EV infrastructure rules went through proceeding over roughly a 2.5-year-ish time frame, ultimately resulting in Electric Rule 29 for both PG&E, and I'll also speak to SoCal Edison down south, Electric Rule 45 for San Diego Gas and Electric. So under those rules, it is not allowed to have applicant install work performed under that tariff. It is an optional rule. And considering that this tariff is still very new, it's 15, 16 months on the books, I would expect that we would see modifications to the tariff over time, right? So I hear you on the concerns around timelines. There is a workshop underway that we're going to have in, I believe, October timeframe. I don't think the date has been set officially, but that will be a joint IOU workshop with the California Public Utilities Commission, and everybody in this room and everybody online is invited to that, because that will be a public forum where we'll be talking about essentially how we're looking at end-to-end execution, where we're looking to realize efficiencies, and how we're trying to improve the business in the areas where we run into just challenges with general timelines. So again, that's a public forum, joint IOU CPUC workshop, and I think it is targeted sometime in early October, but I don't think we've got the date solidified there. So I think there's opportunities to bring what I would consider constructive criticism into a forum like that for how we can improve the tariffs and ultimately help deploy more EV charging infrastructure in the most cost-effective way, because I think that's really the intention behind the tariff. And do you have anything else, Lydia? Because I know you were involved in that. Okay.
Yeah.
All right.
Okay, we are at time. So the session number 2, sadly, I know, has to come to an end. The next panel starts in 10 minutes at 2:55, and the panelists, if you have questions that were not answered, will be here for the next couple minutes. Feel free to pop up and ask them any questions. And really thank you guys all for your great questions and your great participation today. Thank you.